Today, we are going to unveil one of the core notions of statistics. In a simplified way, we are going to explain the meaning of variance, its importance in statistics, and how it is used to extract valuable information in statistics. Consider some data points with a regression line. Let's start with a simple goal. Imagine you measure your car speed during your travel around Europe. Your speed depends on the speed limit on each country. You plot your data from the last trip. Each point represents a checkpoint in each country, the distance traveled across Europe, and the average speed in each checkpoint. To make predictions, we can draw a line of best fit through our data. This line represents our best guess. If you tell me the country you're crossing, I can use this line to predict your average speed. Now look closely at how the actual average speed, our data points, fit this prediction line. Notice that the points are tightly packed around our line. The distance from each point to the line, which we can think of as a prediction error, is quite small. This is a sign of a consistent, predictable relationship. In statistics, we'd say this data has low variance. But what if your data looked like this? The trend line, our average guess, is exactly the same, but the actual data is all over the place. The prediction errors are now much larger. In some countries, your speed was far more than the speed limit, and on others, far less. This data is less consistent and much harder to predict. It has high variance. Variance, in this sense, is a measure of how spread out your data is from the average or expected value. So, how do we capture this spread with a single precise number? For that, we will implement a visual approach using geometry. Let's start with the error for our data points. This is the distance from our actual data to our predicted value on the line. Now, here is the key idea. Consider this error as a distance. Squaring the error will give a positive number, which can be perceived as the area of a square built on that distance. This is incredibly useful because an area is always a positive value, and it gives much more weight to the points that are furthest away from our prediction. We can now do this for every single data point. You can see that points far from the line generate large squares, while points very close to the line create tiny ones. Now that we have the squared error, the area, for all 10 data points, how do we combine them into one final number? Simple. We will average those areas. The result obtained from this average area is nothing but the variance. It is the average of the squared errors, a single, powerful number that describes the overall spread in our data set. Now, how do we use this visual result to give a judgment on our data? It's beautifully simple. A large square describes data that is dispersed from the predicted value, while a small square shows that our data is clustered closely around our predicted value. In other words, when you see a data that is widely scattered with large prediction errors, it produces a large average area, meaning it has high variance. This tells us our predictions are less reliable. And when the data is tightly clustered with small prediction errors, it produces a small average area, meaning it has low variance. This tells us our data is consistent and our predictions are much more trustworthy. So let's bring it all together. What have we learned? First, we saw that variance comes from the errors in our data, the distance between our real values and our predicted values. Second, by squaring these errors, we create positive areas that give more importance to bigger mistakes. And finally, we discovered that variance is simply the average of those areas. It's a single, powerful number that tells the story of the overall spread. This is why looking at an average or a trend line alone is never enough. The average tells you the expected outcome, but the variance tells you
how confident you can be in that outcome. It's the crucial difference between knowing the path and knowing how much you might stray from it. So the next time you see a set of data, don't just ask what the average is. Ask, what's the variance? Because the most important insights are often hidden in the spread. Thank you for watching. If this visual approach helped you finally grasp the concept of variance, consider subscribing for more concepts simplified.